The eccentricity of a hyperbola is a number strictly greater than 1 that determines the shape of the hyperbola, that is, how wide or narrow the opening of the two branches of the hyperbola is. To calculate the eccentricity of a hyperbola, we divide the focal distance of the hyperbola by its semi-transverse axis. In mathematical terms, E equals C over A. The focal distance, highlighted in blue and denoted by C, is the distance from the center to either focus, and the semi-transverse axis, highlighted in green and denoted by A, is the distance from the center to either vertex. For a hyperbola to exist, the focal distance must always be strictly greater than the semi-transverse axis. The closer the eccentricity is to 1, the narrower the opening of the two branches of the hyperbola becomes, and the closer the two foci are to the vertices. Conversely, the further the eccentricity is from 1, the wider the opening of the two branches becomes, and the farther the two foci are from the vertices. In other words, as the eccentricity approaches infinity, the two branches of the hyperbola increasingly resemble two parallel lines. The eccentricity of the hyperbola is now 3, meaning that the focal distance is 3 times the length of the semi-transverse axis. As you can see in the diagram, the opening of the two branches is significantly wider, the two foci are farther away from the vertices, and the two branches start resembling two parallel lines. By contrast, when the eccentricity of the hyperbola was 1.05, the opening of the two branches was significantly narrower, and the two foci were closer to the vertices. Like, share, and leave a comment. Thank you for watching, and don't forget to subscribe to my YouTube channel.